Now that we've discussed address classes in IP version 4, we're going to continue the discussion looking at special addresses such as the local broadcast address, loopback addresses, and other special addresses that you'll encounter in IP version 4. We'll also look at network masks and CIDR, or classless interdomain routing, and we'll see how that affects the network and host portion of addresses in IP version 4. So now let's look at some of the special addresses that you'll encounter in your networking career. The first one is directed broadcast address. A directed broadcast address is used by hosts to send data to all devices on the specific subnet or specific network. In direct broadcast addresses, the entire host portion of the address is populated with binary ones. So as an example, if we have a network of 172.31.0.0, the directed broadcast address is 172.31.255.255. Notice, because this is a Class B address, the first 2 octets denotes network, and the last 2 octets denotes host portion of the address. So the host portion is filled with binary ones. 255 in decimal equates to 8 binary ones. So the host portion is therefore populated with binary ones in both the 3rd and 4th octet. So the address now becomes 172.31.255.255. Routers can be configured to route directed broadcasts. But by default, directed broadcasts are not routed from one physical interface to another physical interface or from one VLAN to another VLAN. There are hacking utilities that you can download and use to launch denial of service attacks or DOS attacks by using directed broadcasts. And thus, for security reasons, it's recommended that the forwarding of directed broadcasts be disabled. This is the default on modern versions of the Cisco IOS. So routers and switches will not forward directed broadcasts from one VLAN to another or route them from one interface to another interface. So here's a sample network. Notice this device, 172.31.0.1, is on network 172.31.0.0. 172 is a Class B network. So the network portion of the address is 172.31 and the host portion of the address is 0.0. This device is sending a directed broadcast to 172.31.255.255 using a hacking tool such as Smurf as an example. In other words, it's sending a broadcast to this subnet 172.31.0.0. Now, a router or switch configured to forward directed broadcasts will forward that directed broadcast to network 172.31.0.0, and all devices on that subnet, including this device 172.31.0.1, will receive that broadcast. So all hosts on that segment will receive the directed broadcast, will accept it. So in other words, the network interface cards will accept the broadcast and forward it to higher layer protocols for processing. The CPUs of every device will be interrupted to process the directed broadcast. Now normally, attackers would send the directed broadcast from the device that they want to attack. In other words, they may be using a different IP address, for example 172.16.0.10. But if they wanted to attack this device 172.16.0.1, they would send directed broadcasts to the subnet 172.31.0.0. In other words, they would launch lots of traffic with a source IP address of 172.16.0.1 to destination 172.31.255.255. All devices on this subnet would then reply back to the source address 172.16.0.1, causing a denial of service attack on that device. So a hacker is getting legitimate hosts on the network to cause a denial of service attack on another host on the network. Now, once again, directed broadcasts are not permitted by Cisco devices these days to prevent these kind of attacks using applications such as Smurf. Smurf is an example of an application that allows you to launch denial of service attacks using directed broadcasts. That's not as common today because routers and switches drop directed broadcast traffic by default. The next type of special address is the local broadcast address. This is used to communicate with all devices on the local network. The address is populated with binary ones, so it looks like this in binary or this in decimal. In other words, all octets are populated with binary ones, which equates to 255.255.255.255. This address is used, for example, by a host when requesting an IP address from a DHCP server. The host doesn't have an IP address yet, so it doesn't know which subnet it belongs to. It also doesn't know the IP address of the DHCP server. So it will send a broadcast to this address, the local broadcast address, to request an IP address from a DHCP server. Just in case you're not familiar with DHCP, DHCP is Dynamic Host Configuration Protocol, and it's a service that provides IP addresses dynamically to devices such as PCs, phones, iPads, IP telephones, and other devices that you may encounter on a network. So rather than you manually configuring IP addresses on your iPhone or your iPad or an IP telephone, or a PC for that matter, you would allow that device to boot up, sends out a broadcast to the local broadcast address, and the DHCP server hears that broadcast and then allocates an IP address to the host from a pool of IP addresses or scope of IP addresses. You've probably encountered this many, many times. So, as an example, at home, you may have a broadband or DSL type router providing wireless connectivity at home so that you can get onto the internet. When your PC or your iPad or other devices connect to that wireless network, they are automatically allocated an IP address. In the same way, when you go to Starbucks or another coffee shop, you may be allocated an IP address by a DHCP server, providing both wireless connectivity as well as IP addresses to client devices. Be aware that local broadcast addresses are always dropped by Layer 3 devices such as routers and Layer 3 switches. You can override that functionality by configuring what is called DHCP forwarding, also called DHCP relay, on your routers and switches. So as an example, if you had a PC or device in VLAN 10, but your DHCP server was in a different VLAN or different network somewhere else in your topology, the DHCP request from the PC or phone would not be received by the DHCP server by default. You would have to configure IP forwarding or IP DHCP relay on the switch or router to forward the DHCP request to the DHCP server. So you would type an example like IP helper address and then specify the DHCP server's IP address on the router or Layer 3 switch. Typically, in this example, the router or switch still blocks the local broadcast. So when it receives that local broadcast from the PC or phone, it drops it, but then sends a unicast DHCP request to the DHCP server on behalf of the PC or phone in VLAN 10. This then allows the router or switch to proxy the DHCP request on behalf of the PC or IP phone. What you need to be aware of is that traffic sent to this address, 255.255.255.255, is dropped by routers and Layer 3 switches. Additional configuration is required on the router or Layer 3 switch if you want PCs in different VLANs to receive IP addresses from a DHCP server in a remote or different VLAN. And that's because, once again, routers and switches drop this broadcast address by default.